So here we're going to talk about the last type of factoring, okay? Here we want to factor difference of squares. Difference of squares. Now, the title tells you what we're doing. Difference means what? Subtract. Okay? And squares indicates that there's two of them, right? Because it's plural, right? With the S. And so we're factoring a difference of squares. Okay? So here's what you need to have a difference of squares. You need to have a perfect square. Perfect square. You need to have a minus sign. That's where the difference part comes. And then you need to have another perfect square. So if you have a perfect square and then a minus sign and then another perfect square, you have what's called a difference of squares, right? If it's not a minus sign, let's say it was a plus sign, then would it be a difference of squares? No. Now, let's talk about what it means to be a perfect square. All right? So, is 9 a perfect square? Yes. Here's why. The square root of it is a whole number. What's the square root of 9? 3. Because the square root of 9 is a whole number, Hayden, that means that it is a perfect square. 9 is a perfect square. Okay? Is x squared a perfect square? Yes, because what is the square root of x squared? X. So it's a perfect square. It didn't provide me with a decimal, did it? Is 11 a perfect square? The square root of it is a decimal, right? So 11 is not a perfect square. So if you have a perfect square and then a minus sign and then another perfect square, then you have a difference of squares. And so here's your first example, x squared minus 64. Now the first thing you've got to do, the hardest part about factoring a difference of squares is simply recognizing that it is a difference of squares. Is x squared a perfect square? Yes. Is 64 a perfect square? Yes. Is this a minus sign? Yes. All three of those have to be true. If any of those is false, it's not a difference of squares. So here's how a difference of squares will always factor. You'll write two binomials. A difference of squares always factors into two binomials. Say two binomials. Two binomials. And it's so easy what you do. You take the square root of the first term, which is what? And you put it here and here. You take the square root of the second term. What's the square root of 64? And you put it there and there. And then the final thing is you put one of each sign. You put one of each sign, so I could go plus minus or minus plus. There we go. We factored a difference of squares. Okay, now let's check our answer. Let's make sure that if I were to multiply this out, I would end up with this. Okay, so x times x is? X times negative 8 is? Negative 8x. 8 times x is? 8x. And 8 times negative 8 is negative. Now what you notice is negative 8x plus 8x is 0, isn't it? And so they cancel. That's why the signs have to be different, right? So they'll cancel. So you end up with x squared minus 64. Is that what we started with? So when we factored it like this, we factored it correctly, didn't we? So now we want to factor x squared minus 4. In order for us to know if this is a difference of squares, we have to evaluate three things. Is my first term a perfect square? Answer yes or no. Yes. It is. Is my second term a perfect square? Yes. Yes. Is there a minus sign in the middle? Yes. Since all three of those are true, you can factor it. Okay, now tell me this. What should I write first? Two binomials, because the difference of squares will always factor into two binomials. Then I take the square root of x squared, which is x, and I put it first. And I take the square root of 4, which is, and I put it last. And then the signs just have to be different. What are they? Plus and minus. I'm done. I factored a difference of squares. Okay, so as we look at this next example, we have x squared minus 8. Before I even factor it, I say to myself, is x squared a perfect square?
Yep.
Yes. Is 8 a perfect square?
Yep.
No, it's not.
No.
The square root of 8 will provide me a decimal, won't it?
Yes, sir.
So I'm done. I stop. Not factorable as a difference of squares, right? Remember, it must meet all 3 criteria. All right, let's look at this example. I have x squared plus 36, and I want to factor it. Is x squared a perfect square?
Yes.
It is. Is 36 a perfect square?
Yes.
It is, because 6 times 6 is 36. Is this a minus sign?
No.
It did not meet all 3 criteria, so I may not factor it, can I?
No, it's not.
So right here I'll say it's not factorable as a what? As a difference of squares. There may be another way to factor it, but I can't factor it like if it's a difference of squares, can I?